Thank you very much. I'd like to thank the organizer for inviting me here and giving me the chance to outline our project, which is titled Utilization of Biomass for the Preparation of Environmentally Friendly Polymer Materials. In fact, the project is mostly a research project. The project started last year, so I'm not able to give you the final results. I will just outline the project itself, the main research lines of the project. And the project is being realized by 9 research groups from Poland, and they are belonging to 5 different institutions, and the leader is the Technical University of Łódź. And the project is partially, to a great extent, financed by the European Union within the European Regional Development Fund. And the consortium, as I mentioned, consists of 5 different units, and the main unit is Technical University of Lodz, with 4 research groups participating from Institute of Technical Biochemistry, Institute of Fermentation Technology and Microbiology, Department of Material and Commodity Sciences and Textile Metrology, and Institute of Technology of Polymers and Dyes. From outside university, there are 4 institutes which participate. Center of Molecular and Macromolecular Studies, Polish Academy of Sciences in Łódź. There are in fact 2 research groups participating in our project. Institute of Biopolymers and Chemical Fibers in Łódź, Central Mining Institute in Katowice, and University of Agriculture in Kraków. And the aim of the project is utilization of various kinds of plant biomass, and in addition some textile waste materials by their transformation with biotechnological methods involving either enzymatic or microbial processes into fibrous polymer materials. And the intermediate products in those transformations are cellulose nanofibers, tactic polylactide, and aliphatic aromatic copolyesters. And these are known to be important raw materials for the production of biodegradable fibrous materials, as well as other kinds of biodegradable polymer composites. And there are major 5 steps of realization of the project. And the first is the sampling and evaluation of starting plant biomass, the sampling and evaluation of biocatalysts, enzymes and microorganisms, application of bioprocesses for the preparation of polymer raw materials, elaboration of innovative fibrous polymer materials, and finally evaluation of practical applications of fibrous polymer materials prepared within the project. And this is outlined on this scheme, and there are major 3 lines of research. First line goes through obtaining, on the basis of plant biomass, cellulose nanofibers. The other line is obtaining aliphatic aromatic copolyesters with participation of glyceride diols. And the third line is the obtaining of tactic polylactide, also with the participation of lactic acid producing bacteria. And if you look on the left, those two, that means cellulose nanofibers and aromatic aliphatic copolyesters, also other substrates, are the raw materials for fibrous polymer composites, which are obtained with virus fillers. In addition, there are also some other composites produced which could be used as packing materials and also as elastomers. And on the left, the major final products, and it's final, but I'm talking about laboratory or a little bit more scale, are technical nonwovens, geotextiles, agrotextiles, filtration materials, also sweat-absorbing inserts, and sanitary textiles. I think Professor Kruczynska will tell you more about those products in her lecture, I think tomorrow. And in addition to the obtaining of those final products, we are performing studies of aging and controlled biodegradation of composites, polymer composites, and on the use of degradation products in agriculture during composting. So the first line is obtaining cellulose nanofibers, and for their preparation, cellulose-rich plant biomass is being utilized. And this includes grass and straw of various cereals, as well as waste fibers from textile industry, like cotton or linen. And the biomass is first pre-treated with physical and or chemical methods, including boiling, steam explosion, or treatment with certain chemicals. And then it's being treated by multi-enzyme complex obtained from Aspergillus niger mold, which is the main enzymatic tool. And the materials obtained like that, and the composites are intermediate for further utilization and for obtaining new functional textiles and nonwovens with potential sanitary or technical applications, such as sweat-absorbing textile inserts, sanitary textiles, filtration materials, geotextiles, and agrotextiles. And as I mentioned, the aging and composting will also be studied of these products. And the scheme on the cellulose nanofibers you see here. So on the left is high cellulose plant biomass, which is the major raw material. In addition, we plan or we do some experiments with textile industry waste fibers. And after the workup, mechanical, hydrothermal, chemical, enzymatic, we are obtaining cellulose nanofibers. And tactic polylactide is another product which we are doing within the project, and its synthesis is performed by chemical polymerization of L-lactide, which is prepared from L-lactic acid. And the latter is obtained by stereoselective fermentation of plant biomass after its saccharization by appropriate enzymes. There's also the major preparation is Aspergillus Niger multi-enzyme preparation on the special properties. And in this case, potatoes, cereal grains, or beet pulp are employed as starting biomass. And the important point is that the microorganism, bacteria used for fermentation were selected by classical microbiology methods from the environment. And the tactic polylactide will be used for fiber formation and thermoforming. And that's the scheme for that. So on the left you have this high cellulose plant biomass. On the right, saccharide plant biomass. And after saccharization and workup, it will be fermented by selected strains of bacteria into lactic acid, and then will be transformed by physical-chemical method into L-lactide, and then there will be chemical polymerization into tactic polylactide. And the third line involves utilization of various oil plant biomass. And these on sequential treatment with lipase preparations obtained from Mucor circineroides and Mucor racemosus molds is being structurized and later on, after appropriate chemical reaction like cycloaddition, hydrogenation, and these materials are transformed into oligodiols, polyols with glyceride backbone. And these oligodiols, polyols will be copolymerized with appropriate reagents in order to produce new biodegradable aliphatic aromatic copolyesters. And these will be used as fillers for preparation of various fibrous polymers and composites. And this is a scheme of the whole procedure. So start from oil plant biomass, such as rapeseed oil, sunflower oil, or flaxseed oil, which we hope to that he has mostly unsaturated fatty acid residues. So the next step is so-called structurization with saturated fatty acids in presence of selected lipases, which are regioselective on position 1 and 3. So after structurization, we can perform cycloaddition reaction by clamping the medium component, and after that we perform control hydrolysis by lipases to obtain so-called oligodiols, and these will be hydrogenalyzed into from esters into ethers. On this way, we will obtain glyceride diols, which will be used for polymerization, copolymerization. And at the end, concluding remarks are that the methods of preparation of these polymer fibrous materials and composites will positively influence development of science-based economy and will increase the innovativeness of connected areas of research and production. And the main recipients of elaborated methods will be producers of fibers and nonwovens from thermoplastic materials, sanitary textiles, filtration materials, geotextile, agrotextile, and packing materials. Thank you very much. Thank you.